advance here. So we're going to go through these kind of things. And I'm going to send this to you in the chat in case you guys go back and look. You go, hey, where's the notes? Well, that's where it is. And I'm going to actually coordinate on this other computer. You guys don't know. I do a dance here that's insane. It's insane dance. All right, I got to go to Canvas. All right, so I'm just going to get some stuff up and running here. So I'm just going to ask you guys if you've ever seen polar coordinates before in your life. Maybe you have, maybe you haven't. Anybody here seen polar coordinates before? You guys know what they're all about? Let me express to you guys what these are about. Polar coordinates and eventually polar curves as well. Okay, it's a graphing, I should say, system that's based really on circles, if that makes any sense. Like your Cartesian coordinates is based on squares. I'm going to say that again. Your Cartesian coordinate system is based on squares. It's the XY plane, and every point there, you know, in that XY plane, you have an X coordinate and a Y coordinate. This is where you get a lot of algebra from. Now you say, well, what about polar coordinates? Well, polar coordinates is two values again. It's going to be R and theta. It's not X and Y. So you say, what? Yes, this is a different coordinate system we're going to learn. And ironically, this system based on circles, not rectangles, actually can be related to our rectangular coordinate system. So we're going to be able to go back and forth. And you say, well, why is that advantageous? Because there's a lot of other curves that do exist that we study that are easier to study and work with if they're in polar form. So where we're headed is to look at some polar curves. And those curves you apply in science as well. So ladies and gentlemen, just to kind of let you guys know, we're opening the door to another system of graphing and plotting. And it's a very powerful system, okay, used in science. So that's the idea. So you might say, okay, well, where do we start? Well, I got to introduce you to a pole, kind of like the North Pole. We said, oh, is there a North Pole? Yeah, there's a North Pole. And then you have this rectangular, I should say, ray known as a polar axis. So we got a pole, we got a polar axis. Now, what I'm going to do here as well is introduce to you guys, you know, essentially the circle graphing system, the polar graphing system that we use. It's circular, and I did superimpose your XY plane on it. Okay, you go, Mr. Judge, you still put that XY plane. Yeah, I did, because I'm going to go back to your past reference and introduce something new. So if you guys see, you go, wait a minute, I see the XY plane, 90 degrees, 180, right? If I take this polar axis, by the way, and I can rotate this counterclockwise, it's a positive rotation. You guys see what I'm doing? We've already been doing that. I could go the other direction. It's a negative rotation, negative angles. So I'm tapping into what you've already done and known, and I superimpose this circular graphing system. This is your polar, coordinates graphing system. It's based on circles. But you need two things. You say, what do I need? I need R. What do you guys think R would stand for? Radius. You go, what do you mean R stands for a radius value? Yeah, if you guys take a closer look, what you have here is circles, don't you? So these are all circles. So every circle has a radius value. Does that make some sense? So if you said, okay, what is that first innermost circle going to be here? Well, my radius, this is a radius value of 1, if you see that point. This is a circle with a radius of 2, of 3, of 4, of 5, of 6, of 7, and so on. So all those circles you see have radius values. So R does stand for the radius. So you go, oh, great, R is a radius. And then what do you think these other lines represent? Right? See this line through the origin, right? If I took that ray, now, you say, what if I took the polar axis and I rotate it 30 degrees? Well, that's your angle what? Theta. So the reason I did that for you guys here is because I want you to understand a couple of things here. R does stand for the radius. R is your radius. Theta is that angle that you rotated before, because this ray is like on the positive x-axis. So theta is positive. This is a counterclockwise rotation. Theta being negative is your clockwise rotation. So ladies and gentlemen, I'm introducing you to this polar world here. We're going to plot points. We need two numbers to plot a point. We need the radius and we need the angle. And all we're going to do is rotate the ray, and that'll be our angle, and we can have a radius value of whatever we want. So ladies and gentlemen, that's what we're going to do here, right? So some of my notes, here's what I kind of described technically on that. We say, okay, the pole and polar axis can be superimposed in a rectangular coordinate system where the pole is centered at the origin and the polar axis is over the positive x-axis. This is what you guys are seeing here in this picture. So I'm tapping into what we already did with what's new. And then I'm going to say here, however, a coordinate described in polar form is a point. This is a point, r theta. Well, we can plot the point P by rotating the polar axis an angle theta, a distance, and we put absolute value of r because r could be negative. We'll talk about that from our pole. Of course, theta being positive means our rotation is counterclockwise, and theta is negative means our rotation is clockwise. So we're going to look at some examples here, ladies and gentlemen. Okay? This is a polar coordinate. So when you see this, what's your radius? Do you guys know? We need a radius value and we need the angle. So when you read this point, the first number is the radius. So r is 2. You guys okay with that? We define it r theta. What's the second number? That's the angle that we rotate, the polar axis. And then that's going to be pi over 3. Isn't that 60 degrees? Okay, you guys okay with that? So we're going to plot that point P. And so you say, well, what do I do? Well, you take that pole, and maybe I'll draw a line now. Here's your pole, right? And I rotate it where? 60 degrees. Does that make some sense? But what's your radius value? 2. So in other words, I go from this pole 1, 2 units, and ladies and gentlemen, this is the location here of that point. It's 2 comma pi over 3. Or we could just label it, we could number it, call it a letter like P. Okay, now really, you don't have all of this. If we can get rid of this, there we go. So there's your location. This is going to be where 2 pi over 3 is. Okay, you guys okay with that? Is that pretty simple? What do you guys think? Is that a simple idea? It's not too bad. It's pretty good. What happened? Oh, now they want to know where is 2 pi over 6. So my radius value here is 2 now, and the angle pi over 6. What's pi over 6? Isn't that going to be, I think that's 30 degrees. Is that right? So let's plot this location now. Okay. So if I take the pole again, and I rotate this, what? 60 degrees. I guess I'm going to have to move this here. I'm sorry, 30 degrees. Good. Let's get that coffee. See that there? But I have to have a radius of what number? 2. So go out 2 units. 1, 2. There's your location. And now you're at 2. If we call that P for point, we're now at 2, what? Power 6. All right. You guys okay with that? There we go. Easy peasy lemon squeezy. All right. Now you say, well, where is 1 pi over 3? So my radius now here is going to be what? 1. And that angle for theta, pi over 3, oh, that's actually what? 60 degrees. Yeah. Okay. So maybe you say, you know, Mr. Judge, I understand what you're doing. I see that line 60 degrees. Can I just use that? I guess so. We could just use that 60 degree line there. You guys see what I'm saying? This is like the North Pole. And so here's the location of our point P, and that's 1 comma pi over 3. So we're plotting these particular points. All right. Okay, what about this one? They want to know where is 5 pi over 4. So your radius here is going to be what? 5. That angle is pi over 4. And pi over 4, isn't that 45 degrees? Okay. You're going to take this ray and you're going to rotate it 45 degrees. Now you say, where's 45 degrees? Well, I don't have it labeled there, but it's between what? 30 and 60. Is that right? So I just want you guys to know this is a 45 degree angle here. But what's your radius? Radius is 5, so I'm going to have to go up 5 units. So you say, okay, 1, 2, 3, 4, 5. So here's going to be the location P, and that's 5 pi over 4. Now, sometimes what people say is what you do, if you guys notice, you can do this in order. You can say, plot your radius first and then rotate the ray. So sometimes people say, go out here 1, 2, 3, 4, 5 units. Okay? And then rotate your ray 45 degrees. So there's your R being 5. And if you rotate 45 degrees, now that ray, right, if I go back here, rotate that ray 45 degrees, you're doing it in order. So you're reading the radius first, and then you're rotating that polar axis 45 degrees. Notice you get the same location here. Okay? So I just want to let you guys know that. Plotting some points. Okay, is that pretty simple? All right, where's 3 pi going to be then? So if I go with that system to say, I'm going to use my radius here, 3. 1, 2, 3. Okay? I have to rotate pi. So I take the ray. Maybe I'll have to do it. Yeah, I'll do it this way. We take our polar axis, and pi, isn't that one full revolution, 180? Ain't that 180? Where's your radius value going to be? 1, 2, what? 3. So this is 3 comma what? Pi. And that's the location of this point if we want to name it P. So you can start by working with the radius first and then rotate the ray. Okay, and that's a point in the polar world. What do you guys think? Is that pretty simple? Not too bad. In fact, you might say, well, how do negative angles work? Well, if you guys remember, how did negative angles work before, right? The radius value is 4. The angle is negative what? Pi over 2. So, if you said, okay, let's plot the radius first. We're going to do R. 1, 2, 3, 4. Okay, there's your circle with radius 4 now. But what angle is negative pi over 2? Do you guys know? Isn't that negative 90 degrees? Right? So that's a negative 90 degree angle. Is that true? Because pi over 2 is 90. All right. Easy peasy. Is that right? All right. So just to kind of let you guys know here, you're going to rotate that down this way. But don't forget the radius was what? 5. So you're really talking about this location. Oops. Let's get this here. This location over here. 5 comma what? Negative 90. I'm sorry, did I screw up? Oh, 4. Sorry. Thank you. I got to get that coffee in me. You're right. It's going to be 4. Let's get this coffee. All right. What about this? What's our radius here, ladies and gentlemen? Radius is 5. What's the angle here? If we say negative 2 pi over 3. Do you guys know what that angle is? That's negative 2 times. What's pi over 3? So that's negative 120. Is that right? Okay. All right. So let's plot where 5 would be on the polar axis. 1, oops, too big. 1, 2, 3, 4. Here's 5. The angle is negative 120. Okay, so what does that look like? Well, is it? Yeah, it's going to be a clockwise rotation. But notice what I do. If I can get that, there we go. Isn't this 90 degrees? Then I have to do another 30 degrees. So I want people to understand this little detail here. This is important. Isn't that a 90-degree angle? But then this is another what? 30 degrees. So what you found is that this is where negative 120 degrees. So we can have negative angles, ladies and gentlemen. But what was the radius again? Wasn't it 5? All right. Oops, that's not where it is. It's where? It's over here. We got to move this all the way. Okay, here. Let's move this. Yeah. Okay, we can call that P. Okay, you guys okay with that? You guys see how we found the negative 120? Negative 90 an additional, and that is clockwise rotation. Okay, because a negative angle is always clockwise rotation. Okay, where is this going to be? 3 negative 5 pi over 4. So my radius here now is 3. The angle is what? Negative what? 5 pi over 4. What is 5 pi over 4 anyway? Isn't that 45 degrees? What's 5 times 45? It's negative 220 what? 5. Is that okay? You guys okay with that? So here's your radius 3. We got to rotate this negative 225 degrees now, right? So if it's negative, what kind of rotation again? It's clockwise rotation. So what that means now is I have to go, okay, negative 225. So this is negative 90. This is negative 180. This is negative 2 what? This is another 30, is that right? So that's 210. And so it's going to be in the middle there. Is that true? Because negative what? Negative 180, and this is going to be a negative 60. That's going to be too much. That's 240, so halfway again. So good, there's a location. But the radius was what? 3. So we have to go 1, 2, what? 3. So here's the point P, 3 comma negative 5 pi over 4. What do you guys think? Is that okay? All right, what about this? Your radius is what? 2. The angle is a negative what? 3 pi over 2. Yikes. Can't even write it. So it's negative. So what is 3 times 90? Mm-hmm. Is that negative 270? Okay, so my radius is going to be 2 now. So you're going to go with a radius value of 2. You go 1, 2. This is on the polar axis. But we got to rotate the polar axis how? Negative 270. Okay? So let's see how to do that. This is negative 90. This is negative 180. Is that true? And then this will be negative what? 270. Did you guys see that? Is that right? So just to kind of put a remark down here, this is where negative 90 degrees would be. Is that true? And this is actually where negative 180 would be as well. So that makes this negative what? 270. So ladies and gentlemen, you found that. But what's your radius? 2. To negative what? 3 pi over 2. Okay, so well, should we do number 10 or should we go on? You guys see the point? How about this? Let's get on to, we don't have to do that one. Let's go to number 12 here. And you go, oh, Mr. Judge, what if my radius is 0? This is an interesting thing. Okay. Your radius can be any real number. So your radius is 0. And you're rotating 2 pi. So let's see where this would be here. So I want you guys to understand an important detail. If the radius is 0, what does that even mean? It means you don't even move from the pole. Is that right? This is the pole. You're not moving. So here's the thing about this. It doesn't matter if your angle is 2 pi or any value. So you go, well, I'm going to rotate this pole 2 pi. Okay, you just did. What I'm saying is that location is the pole. And I guess I do have to remark about this. These points are not well defined. You might say, what do you mean they're not well defined? Well, what that means is you can have any angle for theta. Any angle for theta. If your radius is 0, we are always talking about the pole. Does that make sense? Because you're not even moving any radius value. That's the same as the pole. So what that kind of is saying, I can give you any angle there. If the radius is 0, they can say, what if the angle is pi over 4, negative, I don't know, pi over 6. You're still talking about what? Any angle theta, we're still talking about the pole. So I just want you guys to know the formal definition of the pole, when they start out, is 0, 0. They say this is your pole. But the truth is, there's a lot of addresses that have the same location. So these points are not well defined. I want you guys to say that. And you're going to start to see that in the future. Okay, so there's the pole. That's something we want to be aware of. Another thing we want to be aware of now, I'm going to start to transition, is what happens when you have a negative radius. So we want to consider a negative radius now. So you're saying a negative radius. Yes. Here's what I want to say to you guys here, right? Of course, our radius can be negative. That's r being less than 0. We can use the following relationship to plot polar coordinates with a negative radius here. So here's what this means here, right? You're now going to see a negative radius value for any angle theta. Now, in the back in the day, when they give you these kind of examples and you used a board, it was very easy to show people by your hand. We would use our hands and we rotate on the board with the palm of our hands at a location. Then we have our thumb sticking out and we go, oh, opposite direction. So I want you guys to understand one thing here. What's the relationship between an angle theta and theta plus pi? These are in this relationship. I'm going to say to you guys is it's opposite the pole. So this is the relationship. It's opposite the what? The pole here, ladies and gentlemen. Theta and theta plus pi, 180, that just means opposite the pole. Now you might say, well, what are you talking about? Well, what is a picture of this? If this is r theta, okay, minus r theta, it's the same distance r. This is a distance r. We call that the absolute value of r. Okay, I want you guys to understand that. That distance is the absolute value of r. That's the absolute value of r. But with a negative radius value, it will be opposite the what? The pole. I'm going to show you an example. There's your pole. So we're going to start to plot negative radius. It's very simple, but let me go through how you do that, okay? So here's the deal. You can see in this example, the radius is negative what? 3. And your angle is pi over 2. So you might say, well, how do we do this? What you're going to first do is you're going to plot the positive radius 3 pi over 2. You're going to do this in steps. Number 1, here's your first step. I know your radius is negative, but you're going to plot 3 pi over 2. And you say, well, where is 3 pi over 2? Well, it's right here. 1, 2, what? 3. Because pi over 2, if you guys remember, is in fact 90 degrees. Is that right? But they want us to plot the negative radius value. Well, that is always, now do step 2. Plot the point. Opposite the pole. So what is opposite the pole, ladies and gentlemen? It's over where? Over here. You go 1, 2, 3. So this is the location of negative 3, positive pi over 2. This is what I mean by plot the positive radius with the angle and make sure you go opposite the what? The pole. Down here. This is the location of negative 3 pi over 2. So that's something that we used to show with our hand in the board. We used to plot, oh, here's 3, and then opposite, we'd have to go with our thumb, and that's the problem. Can't show you my hand very easily. You guys know what I'm saying? Can't do that. So this is how we plot a negative radius. It's done in 2 steps. What do you guys think? Isn't it still pretty simple? And of course, you don't really need this, so you know you don't need that part. There it is. All right. What's that? No, you're plotting opposite the what? The pole. So like for this example, again, a negative radius. Okay, so we know, okay, our radius here is what? -4 theta 5 pi over 4, and you can barely see that. You want to plot what first? 4 5 pi over 4. That's what you plot first. And then you're going to look at the location opposite the pole. But what is pi over 4 anyway? Is that 45 degrees? What's 5 times that? Is that 225? So you say, do I plot 4? 1, 2, 3, 4, right? Where is 225? Do you guys know where 225 degrees would be? Let's rotate our ray. Isn't it between right here, 210 and 240? This is 225 degrees. You guys okay with that? But the radius was what? 5 units. So we go 1, 2, 3, 4, and what? 5. 5 pi over 4. All right. We need a negative radius. Oops, sorry, that's supposed to be 4. 1, 2, 3. This is right here. This is 4. Okay, but that's not the point they gave us. Could you guys find what's opposite this pole? Oops. Okay. Let me draw it a little better. One, 2, 3, 4. This is location, -4, 5 pi over 4. You must plot the point opposite the pole. That's how you deal with the negative radius value. Okay, you guys okay with that? Yeah. Which one? Yeah, I'm trying to show you guys opposite the pole. But remember here, down here, here's your pole. So what I did was I plotted the 4 5 pi over 4, and then I put opposite the pole. It's directly opposite. In other words, yes, it must be what? This is pi. And that's why when I gave you guys that concept here for negative radius, where is it? I think it's, oh, no, here it is. Theta and theta plus pi are opposite the pole. This is that angle 180. Yeah. So this here, opposite, this is going to be 180 here. Pi. And actually, I see a typo. We should call, I mean, no. Yes, technically, sorry. It's fine to write it the way I did, but anyway. Okay, so how would this look here? -2, your radius value is what? -2. Your angle theta will be 4 pi over 3. So what's pi over 3? Do you guys know? Isn't that 60? So what's 4 times 60? Is that 240? You have a negative radius. So your angle is 240 degrees. So remember what you do first. Don't you have to plot first positive what? 2 4 pi over 3, which is 240. So you might say, okay, I have to rotate to 240 degrees, right? And there you go. And I think what you got to do is get that line there. Okay, 240. But you have a radius of 2. So that radius is going to be what? 1, 2. So here's 2. What's the other angle? It's 4 pi over 3. Okay, you guys okay with that? But what is opposite the pole now, because you have a negative radius? Right? So it would be opposite that pole. What's opposite the pole here? I'm going to draw this here. This line, and I have to go 2 units here. 1, 2. So that's really the location of negative 2, 4 pi over 3. And that's what you're looking for. So it must be always opposite the pole here. And like I said, this is really pi, 180. That's what opposite the pole would be. And then, ladies and gentlemen, you might say, well, what happens if they give us a negative radius? Well, you guys know what's negative 3, 0. Oh, let's do it. We haven't done negative 3, 0. What's this? R is what? Negative 3. What's theta? 0. Okay. So we notice we have a negative radius. Is that true? So we got a negative radius, ladies and gentlemen. So what do you do first? You're going to plot 3 what? 0. So 3, 0 is really where? 1, 2, what? This is the location of 3, 0. Is that true? Because the angle is 0 degrees. So you're on the polar axis. But we have to plot the negative radius, negative 3, 0. Where would that be? Opposite the what? Pole. So here's where negative 3, 0 is. This is the location here. And then that is, again, notice, this is a pi angle here. So this is why, it satisfies the definition I gave you guys. So this location is positive 3, 0. That's what you do first. But the negative radius is opposite the pole. And your pole's right here. Now, what can happen is they can give you both a negative what? Radius and a negative angle. So R here is what? Negative 4. What's my angle? Yeah, negative 90 degrees. Okay. So you might say, okay, what do I do always when you have a negative radius? What do you guys always do? You plot the what? Positive radius. So 4, negative 90. Where's 4, negative 90 at? You guys know? You got to plot that first, right? Because it's negative radius. Don't we recall this, right? 4 is 1, 2, 3, 4. But if you take your ray and you rotate it, how? Negative 90 degrees. Isn't that where negative 90 is? For negative 90 is where? 1, 2, 3, right here. Okay, you guys okay with that? You guys see that there? For negative 90? But it's a negative radius. It must be opposite the what? Opposite the pole. So what is opposite this pole? One, two, three, what? 4. That's where 4 negative pi over 2 would be, because again, you want it to be opposite that pole here. And that's the location they want you to plot, right in here. That's the P. And let's do it nicer too. What do you guys think? Okay, so you can have a negative radius and you can have a negative angle. I think there's only a few more, which is good. What do you guys think? Is that pretty? How about this? Where is this at? This is going to be, let's write down what it is, right? My radius is what? Negative 2, and my angle is a negative what? Pi over 4. Negative radius again. You always plot the positive radius with the angle, even if the angle is negative. So what is a negative pi over 4? Isn't that negative 45 degrees? You guys know what I mean? Okay. So radius of positive 2, angle negative 45. So let's see, how does that look here? Radius of positive 2. Positive 2, radius is here. Right? What's a negative 45 degree angle look like? Something like this. Is that right? It's negative, we'll put 45. Okay, is that right? And the radius is going to be 2. Says we have to do that in steps. 1. So here is 2 comma negative pi over 4. Okay. So opposite this pole now, my pole is here. Opposite the pole, how many units? 2, is that right? So I go up 1 and where? 2. That's the location of negative 2, negative pi over 4. So this is a very important exercise, ladies and gentlemen. Finding these points. Because, you know, we got to know how to plot points before we do anything else here. Let's look at this one here. See how much we have here. Good. The last one. Good. 20 examples. Oh my God. Okay. Your radius is what? Negative 5, and your angle is negative what? 5 pi over 3. So what is this? If pi over 3 is what? 60. What's negative 5 times 60? Isn't that negative 300 degrees? Yeah, we have a negative radius, but you always plot what? The positive radius value with the negative what angle? Is that right? You guys okay with that? Okay, so 5 is here. 1, 2, 3, 4, and 5. There you guys go, right? So if you have an angle like negative 300, negative angles, this is negative 180, is that right? Where's negative 300 at? Negative 270. Oh. Plus a negative 30. Isn't that negative 300? You guys with me on that? So this is where negative 300 degrees would be. But we need a radius of 5 because remember, we have to start by plotting that 5. This is the first step. So radius of 5, where is that at? 1, 2, 3, 4, and what? So here's 5, negative 5 pi over 3. So don't forget, we have to do what? Don't we need to be where? Opposite, right? Opposite the pole. So opposite the pole for a negative angle. Go down 1. Here we go. 1, 2, 3, 4, and what? Negative 5. Negative 5 pi over 3. Yeah. Well, in all honesty, if you said to me, what should we put on this exam? You want to know what you really want to put? You have a great question. I would say try to communicate to me that you know the answer. You know what I mean? I leave a lot of this up because it's a demonstration, but really that is the answer you're looking at. So you have a great question here. Sometimes what happens is, just as an instructor in a student situation, a lot of times students will write work down and they don't communicate what the answer would be. So you don't know whether they know what the answer is, And so that's always a dilemma for an instructor. And so really, if you want to know the truth, this is the location that you put as an answer. All this other stuff was just partly the what. You don't even have to put the ray at all, All this other stuff is not really there. That's the location. So this is just the location of what they're asking for, And then I think, for example, this is in section. You guys know I'm always balancing between two computers, and it's a nightmare. Let's see. I don't know, I'm trying to look at something here. What is this? How they do that? I don't know. What is this? Let's go to Canvas here. In Canvas, I think I did this here. So if you guys want to look in Canvas here, you see this polar coordinates. I'm going to double check something here. Yeah, that's the worksheet that I just gave you guys. It's there, but I think probably I might send you guys in Canvas you see the graph I just used? You know, maybe you guys can print that graph for yourself and then you can plot in Polar. I don't know. That might be helpful. I don't know. Because when I look at the homework here, you guys want to do, we started chapter 8, but we got a late start. Yeah, it's kind of doing 1 to 12 all to get started with this stuff. But tomorrow we're going to do some conversion, and it's called polar conversion if you want to think of it that way. So there's more work to do tomorrow. So anyway, apologize for the late start, and we'll do some conversion tomorrow. And if you said, well, and I'll make an announcement tomorrow. What are some polar conversion? Let's see, where is this? I might even have some of that for you guys here in Canvas. Yeah, here's some conversion. So I even have some notes for you guys here on how to convert in Polar. We'll start to do some of that stuff tomorrow as well. Okay, so this is a great graphing system that you guys will use in your future. And hopefully you guys found that pretty simple to do. It's just a process. It's based on circles, radius, and angles. And we'll see you guys tomorrow. All right, take care.